Hello, Coach Holmes here, and today we're going to be talking about similar right triangles and how to solve them and finding the length. So, for example, one of the biggest things we have to be able to do is be able to find geometric mean. What does that mean exactly? It is the positive number x where the proportion and I know I'm in the way, I'm sorry, just my writing's a little bit sloppy. A over x equals x over b is true. Now, an easier way to work this out though is by saying x equals the square root of a times b. So basically, whatever two numbers were given to us, we're going to have to multiply them and then take the square root of that. Okay? So, for example, 4 times 9. So I'll do 4 times 9, which gives me 36. I'll take the square root of that, which gives me 6. So the geometric mean of 4 and 9 is 6. Now, 6 and 15. If I multiply these two together, that gives me 90. So I take the square root of 90. That gives me 9.48 if I give it two decimal values. All right. Now, reason why this is important is because later on, when we have to find the length, we have to use geometric mean to find the length of a missing piece of a triangle. Now, let's talk about right triangle similarities though. If altitude is drawn from vertex of the right angle to the hypotenuse, then the two triangles are similar. Okay? Now, I know it's kind of difficult to see, but for example, if this angle is A, B right here, this is going to be A, this is going to be B. All right? And that's how we'll be able to figure out which one goes where. So for example, if I have triangles, and this is how the triangles are similar to each other. If I have X, Y, Z, if you think about it, I'm going from A, right angle, to B. So if I look at triangle number 1, I'm going from triangle X, W, Y. Because remember, I'm going from A, right angle, B. And to find the third one, for the second triangle, I'm going from Y, W, Z. Okay? And that's how I determine how these three triangles are similar to each other. That's how I'll be able to determine that. Next, we have geometric mean theorem. This is where we're actually going to start using geometric mean, because it actually helps us to find different lengths of a triangle. So for example, if an altitude is drawn from the vertex of the right angle, then the altitude is, I want to put GM for geometric mean, between two segments of hypotenuse. Okay? I want to find the altitude between two segments of the hypotenuse, if that's be given the case. Another possibility is that each leg of the triangle is a geometric mean between the length of the hypotenuse and segment of the hypotenuse from the same side. Okay? So first off, this triangle right here, this is a good example of geometric mean number 1. Okay? So I have an altitude here. This x is going to be equal to the square root of 3 times 14. Okay? So I got to be able to determine what x is. So first off, I know that x is going to be equal to the square root of 3 times 14, which is 42. Or at least, let me start over. I know I set it up like this because it's one part times the second part. So 3 times 14, which gives me 42. I take the square root of 42, 6.48. So the altitude of this length is 6.48. That's the length of x. Now, if I want to find each of these lengths, x and y, basically I have to find the length of each leg. So this is how it's going to work. So if I'm solving for x, one part of it is the part that is on the same side, as well as the whole length itself. So basically, it's the part of the segment times the whole length. So 2 times 6, which gives me 12, and the square root of 12, 3.46. And that's how we're going to be able to solve for x. Now, if I'm solving for y, I'm doing y equals square root of 4 times 6. Because now the 4 is on this side with the y. But I still multiply by 6. So I'm doing 4 times 6, which is 24. The square root of 24 is 4.89. Okay? So, what we're looking at here, what we're really looking at is that for geometric means, they actually help us to determine the length of part of the right triangle, given that we have an altitude that allows us to not only separate it, but also find the altitude itself. So we use geometric means to help us find each length. All right? So, just remember with geometric means that we're multiplying the two numbers and then taking the square root of that. Thank you and have a good day.